Hello, this video is for Module 2 Part 1 and includes some assistance for Homework 2.1. Okay, let's go ahead and get started then. So Homework 2.1 is going to use the hospital recommend data. This is another data set that was obtained from the CMS website, Hospital Compare website, and contains information from a survey that is done nationwide regarding the stay that patients have at hospitals. Okay, the main outcome that I care about is, do they recommend this hospital? So there's a question on that survey about recommendation of the hospital, and the number provided here is simply the proportion of people that said yes, they recommend that hospital. There are many predictor variables that are available. Some of those that are important include, do the doctors treat the patients with respect? Do nurses treat the patients with respect? Are the rooms clean? Things like that. So there's a lot of potential predictor variables here for this particular data. This data also contains two columns, one to identify whether or not it's in the test set or the training set for my split sample cross-validation, and then another column that identifies the fold that a particular observation is in for the k-fold cross-validation. Okay, so let's look at the COLAB document for this particular homework assignment. It's going to be set up pretty much the same here. We're going to load tidyverse, we're going to read in the data, we're going to look at that data to make sure it was read in correctly. Here in this code chunk, okay, I have where I'm breaking the data into a training set and then also breaking the data into a test set. So this is for my split sample cross-validation here. Okay, so when I'm looking at these particular data sets here inside of Google Colab, now these are getting kind of wide, so you got to kind of scroll back and forth here. But this first data frame is for my training data here. As you can see, they're all train here. And then the second data frame that I created has all my test cases in it. Okay, so I have split that data again into the test and train set. There are about, about 3,020 or so hospitals in my train set, and there's about 1,000 or so in my test set. So I did a 75-25 split here with this data. Okay, the model that I'm going to fit for this particular homework assignment, the response is going to be yes, or the proportion of people that recommend the hospital. So yes, recommend is my response variable. I've listed here, 1, 2, 3, 4, 5, 6, 7 or so predictor variables. I did a bunch of modeling before, and I've identified these kind of as the important predictor variables. So I'm not going to go through the process of trying to identify which of these predictor variables I need to use to build my model. Okay, I've already identified that previously, and I just want you to fit a model with these, I think it's 7 predictor variables. So here is the process by fitting that model. I'm going to get my my variable importance plot for that model. So I'll have you talk about that in the homework assignment. And then I'm going to create kind of my scatter plots that we create in order to identify whether or not the model is doing well in terms of the predictions. So here is my actual versus predicted plot. And then on the right is my prediction errors versus predicted plot. And again, I'm just looking at these to make sure that the predictions are doing well. They do have a pretty strong trend here. I think my R-squared for this model is around 65% or so, so that's a pretty good model, all things considered. Once I have my final model, then I need to use that model to make predictions for my test set. So that's what I'm doing here next. Okay, so notice in the code, I'm always using the test set for all of this analysis here. Again, this is giving me a true predictive ability of my model. So if we look here on this data, this should all be my test data. So if I slide over here and look, these are all my test cases. Okay, And I am getting the predicted and my prediction errors for all of those. Now this data frame right here has, what is it, about 1,000 observations in it or so. Once I have my predictions and my prediction errors for my test cases, so the data that's in the test set, then I can compute my RMSE, my R-squared, and my MAPE. And that is what is done with this code chunk here. You're going to have to run this code chunk, grab this output, and then talk about what that output is in the homework assignment here. Now when I do much of the same for k-fold cross-validation, except I'm not going to be using the train and test groups, but I'm going to be using the labels that were in the CV k-fold groups column. Okay, so here I'm going to be, if I look at that data quickly here, let me just show you that. I need the information about what fold each of the observations belong into. Okay, so that first observation is fold 7, fold 5, fold 5, fold 10, all the way down. I used a 10-fold cross-validation in this homework assignment here. I'm going to fit then that model to each fold and then make a prediction for the fold that was withheld. What I ended up doing here was creating a function or a custom function to do that for us. Now this custom function is kind of ugly. It's a little long there. Okay, but it does save me some effort when I need to fit the model repeatedly for each of the folds. You're going to have to run this code chunk, okay, before you're going to be able to get the output down here below. So once again, everything in COLAB has to be run sequentially. When I run this function, which is called k-fold cross-validate, I just need to specify what fold is being withheld. It's going to go fit the model, and it's going to make the predictions, and it's going to compute the RMSE, the R-squared, and the MAPE for me. So running this code chunk here is going to provide information about the metrics or the predictive ability of these models for each of the folds. Now on your homework assignment, you're going to have to take these values from fold 1, fold 2, fold 3, all the way fold 10, and compute an overall performance metric for k-fold cross-validation. So you're going to have to take these values, again from fold 1 here, drop them into a spreadsheet, take these values from fold 2, drop them into a spreadsheet, all the way down, clear down for fold 10, drop them into a spreadsheet, and then compute the average RMSE across all 10 folds, the average R-squared across all 10 folds, and the average MAPE across all 10 folds. And that'll give me a overall predictive ability when using k-fold cross-validation. So a little bit of calculation there for the homework assignment. Lastly, I want you to, in part B, is to identify particular hospitals. So here is what I did here in part B was just used all of the data. Okay, I did not do any cross-validation steps here because I'm just trying to identify particular hospitals. The hospitals that I want you to compare are going to be labeled on your homework assignment, and they're going to be these 3 that are way here on the left. In order to identify them, you're going to have to be able to obtain the predictions and prediction errors. Again, running this code chunk will save those things into my sample data folder here. You will need to download those and open those up on either Excel or Google Sheets. That file is going to look like the other file that I had, with the exception that it's going to include the predicted %yes and the prediction errors. Okay, so you're going to use these columns here to talk about part B of the homework assignment. You're going to have to identify particular hospitals here that have, as I mentioned, very low predicted %yes values. So you might have to sort this data by those %yeses in order to identify those hospitals. Okay, that gives you a little bit of assistance for homework 2.1. Let me know if you have any questions. Have a good day.